My name is Kyle Hecker, and this is IQE number 4 for Fluids 307. The first question, the conceptual question is, what is a radial flow device, and which equations can be used to help analyze it? The answer to this question is a radial flow device is a fan or centrifugal pump involved in the flow in a radial direction normal to the axis of rotation. And then to help analyze what this is, so how to analyze what a radial flow is, a radial flow device, you can use an angular momentum equation and the conservation of mass equations, as mass has to be conserved through the flow of a radial flow device. Then for the calculation question, it reads, what water is being ejected from a line at 39 meters cubed per second with a diameter of 55 centimeters? Before it reaches the end, however, there is a vertical opening of 5 centimeters for water to escape. What is the force in the x and y directions, as well as the total force? So what we know is the diameter in x and the diameter in y of the little thing coming off the top, as we can see in this little picture here. And we have the total flow rate, volumetric flow rate. So we have to find the force in the fx and the fy direction, as well as the total force. So the magnitude of these. We assume the unity conversion factor is 1, and that density of water is 1,000 kilograms per meters cubed, as that is also a property. And then we go to our solve. So we have a little picture here, and then we have a volumetric flow rate. You can start off by getting your mass flow rate, which is just a little algebra with this equation, and you get a mass flow rate density times the volumetric flow rate of 39,000 kilograms per second. Then you can take your or solve for your velocity in each direction by manipulating your volumetric flow rate over your area. So the velocity in the x direction is the volume over the area, which was the 55 centimeters, so 0.55 meters, which gives you 164 meters per second. And then the exact same thing for the volume or velocity in y. Then for fx, you only have out and unity is 1. So fx is equal to 39,000 times 164 meters per second gives us 6,400 kilonewtons. Fy is the same, but this time we get 7.75 times 10 to the 5th kilonewtons, which is a much larger force because it's going through a much smaller area. Then to get the total force, you do the magnitude. So each value squared addition to each other, and then square root, and you get 7.75 times 10 to the 5th kilonewtons, which seems like Fy, but it's Fy plus Fx. Fx is just much smaller than Fy.